All right, hello everybody, and welcome to the last episode of the binge watching assignment that you have for the weekend. So, in the previous two videos, we talked about the well ordering principle and Zorn's lemma, and promised us that these two seemingly technical results are actually equivalent to a familiar one, something that we have seen in the beginning of our axiomatic development of set theory, namely ZF9 or the axiom of choice. All right. So this video will be dedicated into expounding on what the axiom of choice means, what is its actual, or how do we illustrate the axiom of choice in elementary set theory. But we will avoid going into the consequences of the axiom of choice because, like the well ordering principle and the and Zorn's lemma, the nice results that came from the axiom of choice are actually embedded into other major courses like modern algebra, topology, geometry, even real and functional analysis. And so at the moment, we don't have the necessary tools in order to appreciate what the axiom of choice puts into the table. So kaya medyo focused lang tayo dun sa pagkaka-state at ano yung illustration ng gamit ng axiom of choice. Now, the axiom of choice, as we have just mentioned, is the ninth axiom in the Zermelo-Fraenkel set theory. Although early on there are a lot of criticisms and reluctance to include the axiom of choice into the Zermelo-Fraenkel set of axioms for set theory, because most of the things from Cantorian set theory can be proven or can be deduced from the first eight axioms of Zermelo-Fraenkel. So mukhang ang sa tingin ng iba, yung notion ng set theory hindi kailangan yung axiom of choice. However, Ernst Zermelo actually insisted on including the axiom of choice into his brand of set theory because this brings forth, or this is actually required in his proof of the well ordering principle. And the well ordering principle is a very important result, not only in set theory but also say in real analysis, which is the foundation of the calculus that we know. All right. So ibig sabihin may additional na nabibigay yung axiom of choice. But if you take away the axiom of choice from the Zermelo-Fraenkel set theory axioms, meron pa rin mga theorems na nandun pa rin, and they are equivalent to a respective version into the Zermelo-Fraenkel set theory with ZF1 to ZF8. So ibig sabihin yung mga results of set theory using the nine Zermelo-Fraenkel axioms will have a or can have an equivalent to the Zermelo-Fraenkel using only ZF1 to ZF8. Kaya medyo merong mga criticisms at reluctance sa pag-accept ng axiom of choice as an additional axiom for set theory. However, before that, another criticism is that the axiom of choice actually parang binibigyan tayo ng way para dayain yung mga proofs because the axiom of choice can construct, or this can be used to construct objects that are intangibles, some objects that seems to be counterintuitive. For instance, in calculus, the axiom of choice is used in order to create a non-measurable set. So makikita nyo to when you go to math 155 or 156, or even if you go to graduate level real analysis na tinatry nating i-define kung ano yung measure ng isang set, all right? Which is more abstract than what we can discuss right now. But essentially, sa lahat ng function, lahat ng sets in the real world ay measurable. But of course, mathematicians would like to stretch the uh, the the realm of what is possible. Now, with the axiom of choice, we were able to define non-measurable sets that would otherwise will not exist if we don't accept the axiom of choice. For instance, halimbawa naman sa functions, halos lahat ng functions ay integrable in the sense of Riemann. I mean, lahat ng mga functions that have that have physical applications, like those that will be used in engineering, in other physical sciences, are integrable in nature. But we mathematicians thought of, okay, meron nag-exist ng mga functions na hindi talaga integrable, even in the sense of Riemann or Lebesgue. So, and then those functions can only be defined using the axiom of choice. Kaya sabi nung iba, all right, you have your axiom of choice, but the objects that the axiom of choice will say that exists are intangible in reality. So parang the axiom of choice opens the floodgate into objects that are really non-tangible or that are not actually physical in nature. All right. So yun yung tayong criticism. But for the sake of the nice results that came from the action of choice, like the well-ordering principle or the Zorn's lemma, and all of their consequences, like Tikhonov's theorem, uh, existence of maximal ideals in modern algebra. What else? The existence of a basis for all vector spaces, naging acceptable na isama yung axiom of choice into the basis for our modern set theory. All right. So now we will take a look back again at what the axiom of choice and what it says. But I think this nice figure, the figure on the right, gives a nice representation for the axiom of choice. Ang sinasabi niya lang, kung meron kang, halimbawa, parang meron kang jars of different objects or different balls, right? Then the axiom of choice is simply saying that there's a way, there's always a way of picking out one element among those per base. So parang meron tayong paraan para makapili ng isang laman ng bawat jar. And it seems very simple, right? Sa bawat isang jar, pipili ako ng isang representative, and I can do it even if there are a finite or infinite number of jars. So yun yung parang intuitive notion ng axiom of choice. There's always a way on how to choose a representative among all of these jars. And it doesn't matter if you have a finite number of jars or an infinite one. All right. Now let's look at it more formally. But first, we need to define what the choice function is. Now, in remark 14, it says it gives us a nice notion of what the choice function. All right. So it says essentially a choice function for a given family of sets chooses an element from each set in the family. Perhaps siguro nakalimutan ko yung actual definition. There you go. Natakluban ko nga. Yeah, I was just surprised that I will start with the remark. But tingnan natin ano yung definition ng isang choice function, all right? So here let's consider a set S. A choice function for S is a function f from the set of all non-empty subsets of S to S with the requirement that f of A, the function value under f of a subset of S, is an element of A for every non-empty subset A of S. So ibig sabihin, ang isang choice function, si little f, ay isang function na ang domain ay ang power set ni S minus the empty set, papunta ang codomain niya ay mga elements ni S. Ano yung requirement? So maraming mga functions mula sa power set of S less the empty set papunta kay S. Pero para maging choice function siya, ang function value dapat ng isang non-empty subset of S. Di ba remember, ang laman nitong set na to ay mga non-empty subsets ni S. So pag kumuha ko ng isang non-empty subset ni S, sabihin natin siya si capital A, dapat ang function value ni A ay member niya. So essentially, ang ginagawa lang talaga natin, pumipili tayo ng isang member ng isang non-empty subset to be its representative. Now, in our analogy earlier, all right, going back to this picture over here, you can think of the subsets of S to be the jars. So bawat isang jar dito, pwede niyong isipin as a non-empty subset of capital S. All right? Tapos ang sinasabi ng ang isang choice function ay isang function which assigns to each non-empty subset, or in this case assigns to each jar, all right, an element of the subset. In this case, an element or what do you call this? An entry or an element of the jar or something inside the jar. So, ibig sabihin, kukunin ko yung function value ni A1, pipili lang ako dun sa mga laman ng jar A1. Tapos, ano ang function value ni A2? Pipili ako or bubunot ako ng isa dun sa mga laman ni A2 and so on. And then the resulting selection is actually, or the resulting assignment would be a choice function. And so that's where remark number 14 will come in. Essentially, a choice function for a given family of set chooses a representative from each set in the family. Right? So yun yung pinaka-analogy. Let's look at a concrete example. Illustration 15. Let's consider the set capital A consisting of two members, B and C. Tapos, kunin natin yung power set ni A less the empty set. So, kukunin natin lahat ng posibleng non-empty subsets ni A. Meron siyang dalawang laman at alam natin yung sarili niya ay subset niya. So, nandun si BC. Tapos, kukunin natin yung mga subsets ni A na tigi-tigisa yung laman o yung mga singletons. So, we have the set containing B and the set containing C. And we know we're done. We have enumerated all non-empty subsets of A because A has two elements. So yung power set niya, alam natin may 2 to the power 2 na elements. So that's gonna be 4 minus 1 kasi tinatanggal natin yung empty set. So tatlo yung ina-expect nating members. All right? Now, we can define a choice function on the power set of, or a choice function for S. So take note of the preposition. When we say it's a choice function for S, ibig sabihin function siya sa power set ni S minus the empty set papunta kay S. So this F, all right, is a choice function. Bakit? Kasi sa bawat non-empty subset, nag-a-assign tayo ng isang member ng non-empty subset na yon. Halimbawa, yung unang non-empty subset niya, set containing B, ang function value niya under F ay si B. All right? And B is a member of the set containing B. Now, the function value of the set containing C is C. Kasi nga, para maging choice function si F, dapat yung function value ng isang non-empty set, dapat ay laman niya. All right? And then, what could we assign to the set containing BC so that F will be a choice function? Well, I could assign C to the set containing BC because C is contained in the set containing BC. So this is indeed a choice function because every non-empty subset of A is mapped to one of its members. Parang pumili lang talaga tayo ng isang representative mula sa lahat ng non-empty subsets ni A. All right? And essentially, that's what a choice function is. All right? Now, actually, there's another choice function that we can define for the set A. Right? At ayon yung function G rito. Of course, I don't have any choice but to assign B to the set containing B and C to the set containing C kasi tigisa lang sila ng laman, so dapat yung laman nila sila yung maging representative. But for the set containing BC, we have two options as the representative. Kanina inassign ko si C and I said I got a choice function. Now, if I will choose to set G of the set containing BC to be B, I will still get a choice function. All right? Kasi ang naka-assign sa kanya ay isa niyang element. Now, G will not be a choice function if I will choose to assign the set containing BC to A. Hindi na siya magiging choice function or it will not be a choice function anymore because the assigned value for the set containing BC is A, which is not among its members. All right? So I hope it's clear what it takes to be a choice function. And this example shows that there could be more than one choice function for a set S. All right? Now, let's go to remark 16. And it says that although a choice function is defined for a family of subsets, any family of sets can be considered to be a family of subsets of their union. Medyo maigpit yung definition natin kanina ng choice function. Sabi natin, Ang isang choice function para kay set S, ang domain niya dapat ay set of all non-empty subsets. Alright? Pero pwede nating i-relax ng konti. Pwede nating sabihin na pag meron lang akong collection ng mga sets or if I have a family of sets, pwede ako mag-define ng choice function doon. So hindi necessarily na ang domain dapat ay power set less the empty set. Pwedeng isang collection ng mga sets ang gagawin kong domain, tapos ang codomain niya ay yung union ng mga elements dun sa family. All right? Now, to illustrate remark 16, we have exercise 17 over here. Okay. Nagbigay siya ng tatlong sets, A1, A2, and A3. So, itatry nating tingnan ano yung lighter version ng choice function na pwedeng i-define sa union ng tatlong sets na to. All right? So, the first set is set containing 1, 2, 3. A2 is the set containing 1, 3, 4, and the third set is 2 and 5. So what we'll do is to check, okay, if this assignment and this assignment are choice functions from. Ano dapat yung magiging domain natin? Ang domain dapat nung choice function natin ngayon ay set containing A1, A2, and A3. Right? And then the codomain will be the union of A1, A2, and A3, which would be the set what? 1, 2, 3, 4, 5, and we will call this the set B. Right? So ito yung sinasabi natin na lighter version, quote unquote, ng isang choice function. Meron kang specific family of sets na iniisip na kagad to be the domain. So naisip ko ngayon na domain ay si set containing A1, A2, and A3. So tatlo lamang yung hanapan ko ng representatives. Tapos ang codomain ng choice function na i-define ko rito sa set na to ay yung union ng mga elements ng family. So I'm going to take the union of A1, A2, and A3. Tapos 1, 2, 3, 4, 5 lang naman siya. So ibig sabihin, pipili tayo ng function value para kay A1, para kay A2, para kay A3, at yung mga function values na yon nanggagaling dun sa union, which would be the set containing 1, 2, 3, 4, and 5. Okay? Now, the requirement is still there para maging choice function yung given assignment. Dapat ang function value ng isang set ay dapat member niya. So bawal pumili ng outsider mula dun sa set, right? So in this exercise, you are asked to determine whether the function f and g are choice functions. So you can pause the video and try this exercise on your own first, and then I'm gonna go back in a moment and reveal the answers. All right? All right, I'm back, and I hope you have written your answers. Let's check if the assignment F in here is a choice function. All right, let's see. So here, again, ito yung domain. Ang codomain ay yung union ng A1, A2, and A3. Now, F assigns A1 to 3. Question, is 3 a member of A1? Now, this is A1. Clearly, 3 is there. So, yeah, okay, that's fine. That function value is okay. However, when we go to A2, in F, A2 is assigned to 2, but 2 is not among the members of A2. Wala si 2 kay A2, and yet F insists na ang representative dapat ni A2 ay si 2. So, ibig sabihin, the function F is not a choice function. All right? Now, let's go over G and check if it's a choice function. All right? Here, A1 is assigned to 2, and good enough, 2 is a member of A1. Now, A2 is assigned to 4, and 4 is a member of A2, so everything is good so far. And finally, A3 is assigned to 2, and 2 is another member of A3. So the function G here is a choice function for the set containing A1, A2, and A3. All right? So I hope you get the right answers there. So if you have any questions, just give me an email or a chat or drop a comment in the comment section. All right. So yun yung pagiging choice function. Tapos anong sinasabi ng axiom of choice? Sabi ng axiom of choice, which again is not new to you, we have seen this as ZF9 when we started axiomatizing set theory from Cantor's to Zermelo-Fraenkel's, right? Now it says that there exists a choice function for any non-empty family of non-empty sets. So sabi niya lang, pag kumolekta ka ng mga non-empty sets, at least may isa, lagi ka raw may mahanap na choice function. All right. And this is why, or this is what spurred the criticisms for the axiom of choice. The axiom of choice, as the well ordering principle and Zorn's lemma, claims the existence of something without constructing or even at least providing a way of constructing that object. Sinasabi ng axiom of choice, pag meron kang collection, non-empty collection of non-empty sets, lagi kang may mahanap na choice function. Kaya lang, hindi niya sinabi kung ano yung itsura ng choice function. Hindi niya sinabi, how can we construct the choice function? It doesn't even say how many choice functions there are. All right. So that's why the axiom of choice is criticized, because it is opening the floodgates into the possibility of just asserting the existence of certain objects that are intangible. These objects might be counterintuitive, or these objects might not arise in nature. Pero ang sinasabi ng axiom of choice, paniwalaan nyo na may nag-exist na choice function. All right? So, but essentially people and mathematicians were convinced na, all right, the axiom of choice should be one of the axioms in set theory for the sake of whatever is to follow. And anyway, it seems that the axiom of choice is natural, right? Kaya nga dun sa joke ni Bona na about the Zorn's lemma, well ordering principle, and the axiom of choice that we mentioned in the last video, sabi niya, the axiom of choice is obviously true. The well ordering principle is obviously false. And Zorn's lemma, who can tell, right? So kaya, yeah, self-evident ang axiom of choice. At saka, kung babalikan niyo yung analogy natin at the start when you're drawing balls from urns or from jars, parang napaka-intuitive niya lang talaga. Pero of course, mathematicians and philosophers will stretch every idea and try its limits. See if there will be paradoxes. All right. So yun nga. Parang nasa isip ng mga tao, okay, magagamit tong axiom of choice uh, para masabi na may nag-exist ng mga bagay na posible maging counterintuitive, but we eventually decided, yeah, we can live with that as long as there are no paradoxes because of for the sake of what is to follow. Because you will see that the axiom of choice or the well-ordering principle or the Zorn's lemma is embedded. It is pervasive in the fabric of mathematics. So nandun talaga sila. Mag-creep in yan into any possible area of mathematics that you want to study. You go to algebra, you will encounter one of these three results. You go to calculus or real analysis, or you go to geometry, these things will be there. All right? Kaya nga, or mahalaga sila. But unfortunately, again, in Math 101, we cannot further venture into or probe the consequences or the usefulness of these three results. Kasi kailangan natin yung machinery ng halimbawa modern algebra para pag-aralan yung application ng axiom of choice, Zorn's lemma, and well-ordering principles sa algebra. The same thing goes from calculus and so on. But we will be remiss if we will not at least illustrate these basic results kasi nga set theory tayo and nasa foundational course tayo, right? So I hope you will appreciate these three things or these three results when you come to your major courses, all right? Now, before we call it a day or bago natin tapusin yung binge watching nyo, tingnan natin yung another version ng ZF9. It says here that ZF9 is equivalent to this thing, so you can replace the axiom of choice by this version, which talks about yung pagiging non-empty ng cross product ng isang family of non-empty sets, right? Formally, it says that the product of a family of non-empty sets indexed by a non-empty set is empty. All right? Ibig sabihin lang ng isang family of sets. So, kokolekta ka lang ng mga sets. Tawagin natin silang mga AI. So, yung bawat isang AI ay isang set, isang non-empty set. For instance, AI is non-empty. Siguro, lagay ko na lang dito. So, we will be collecting into a family, tawagin nating family F, yung mga A sub i's. Tapos sabi nung version ng ZF9 na dapat yung mga A sub i's ay non-empty and they are indexed by a non-empty set, I coming from capital I. Yung mga subscripts, yun yung tawag natin, yung mga indices o mga subscripts, nanggagaling sila sa isang non-empty set. Example ng isang family, yung family natin kanina, yung A1, A2, and A3. You can think of them as the family AI, where AI is non-empty, and I is an element of the set containing 1, 2, 3. Right? Etong set containing 1, 2, 3, ito yung tinatawag natin na indexing set. Kasi yung mga elements ng indexing set, sila yung ginagamit natin na index o subscript dun sa pagle-label ng mga sets natin. So if you will write it in roster method, A sub I, or the family curly F, is just A sub 1, kasi nga A sub I, pero yung mga I nanggagaling mula sa set 1, 2, 3. So A sub 1, A sub 2, and A sub 3. Right? And then we know that A sub 1, A sub 2, and A sub 3 are non-empty. Sila pa rin itong mga sets na to mula dun sa kanina. Right? Pinaparticularize ko yung example dito. Ang sinasabi ng bagong version ng ZF9, pag kinuha natin yung Cartesian product, so if we take the Cartesian product of AI, I going from 1 to, or I element of capital I, or in other words, this is just A1 cross A2 cross A3. Ang sinasabi ng other version ng ZF9, dahil yung mga A sub i's natin ay lahat empty. Tapos yung indexing capital I natin ay non-empty because it's the set 1, 2, 3. Ito raw cross product na to ay hindi pwedeng maging empty. Right? That's basically what the new version of ZF9 is telling us. Okay? Then let's illustrate how this is, how does it make sense? Nandun siya sa remark 18. In remark 18, we say that the Cartesian product of the sets A sub I is the set of all functions, or the set of all choice functions. But here I would like to modify it a little bit, and I want to say that the sets A sub i's is determined by the set of all choice functions of this form. So, ibig sabihin pala, another way of constructing the cross product of three sets, or a set indexed by a non-empty set, actually is to look at the choice functions. So, nagkakaroon tayo ngayon ng connection between choice functions and the cross products. All right? So, halimbawa, paano ko to illustrate? So, yung set of all choice functions on the family of sets daw ay parang equivalent, we'll talk about equivalence later, ay equivalence or pwedeng masulat in a one-to-one correspondence with the Cartesian product of the sets. Right? Let's illustrate that here. Okay. Kopyahin ko lang yung itsura ng sets A1, A2, and A3. Kailanganin ko sila. Then let's do it here. Okay. Okay. Ang sinasabi ng bagong version na anong remark 18, yung cross product daw ng A1 cross A2 cross A3 is determined by the set of all choice functions for the family containing A1, A2, and A3. So bawat isang miyembro ng A1 cross A2 cross A3 corresponds to a choice function. Right? So nandun yung one-to-one correspondence nung cross product dun sa set of all choice function. So tingnan natin, pwede nating ihilera yung members dito ng cross product. Tapos nandito yung corresponding choice function para sa kanya. Alright? So tingnan natin yung mga first few elements ng A1 cross A2 cross A3. There would be a lot of them because remember the cardinality or the number of elements of A1 cross A2 cross A3 is the product of the number of elements of A1, A2, and A3. May tatlong laman si A1, may tatlo si A2, may dalawa si A3. So therefore, we are expecting 18 members of the cross product. And then remark 18 is telling us merong 18 posibleng choice functions ang i-define mula sa set containing A1, A2, A3 papunta sa union nila. Right? We just happened to solve one of them in the previous exercise, pero tingnan natin ito. Alright? Now, tingnan natin yung unang member ng A1 cross A2 or kumuha tayo ng isang member ng A1 cross A2 cross A3. The only requirement is that the first component of our ordered triple will be coming from A1. Piliin ko si 1. Second member or second component will be coming from the set A2. Let's get 1 again. And then the third member will be coming from A3. Let's take 2 for instance. So si 1, 1, 2 ay isang element ng A1 cross A2 cross A3. Now remark 18 is telling us there is a choice function corresponding where? It's a choice function from the indexing set papunta dun sa union ng mga A sub i's. Right? So choice function mula sa indexing set. Remember dito ang indexing set natin ay set lang ng mga subscripts. Subscripts ng set dun sa family. Meron tayong A1, A2 at saka A3. Kolektahin niyo yung subscripts nila, yun yung indexing set natin. So ang indexing set natin ay set containing 1, 2, and 3. Now, the remark is telling us that for this ordered triple, there will correspond a choice function from the indexing set, or actually not just from the indexing set, but you can think of it as a choice function from the set containing A1, A2, and A3 towards the union of A1, A2, and A3. So parang ganito yon. So para sa set A1 or para kay 1, pwede ko siyang i-map kay yung unang element nung cross product. I-map ko siya kay 1. Si A2, i-map ko siya kay 1 din. Tapos si A3, i-map ko naman siya kay 2. And this is, you can check that this is a choice function because A1 is mapped to 1, which is one of its members. A2 is mapped to 1, and 1 is one of its members. And A3 is mapped to 2, which is also one of its members. So this assignment is a choice function from from the set containing A1, A2, A3 onto their union or into their union, right? Now, ito rin yung, and then there is an equivalence to it, right? So tingnan natin yung nandun sa example kanina, yung napakita natin to be a choice function. We concluded earlier that this assignment is a choice function on the set from the set containing A1, A2, A3 to its union. Alam na natin yan ay choice function. Now, remark 18 is telling us, meron yung equivalence. So pag meron kang choice function, makakakuha ka ng isang element ng cross product. And how do we do it? The assigned value for the first set A1 should be the first component. So 2 goes there. The assigned value to the second component must be, or to the second set, would be our second component. And lastly, magagaling siya, o yung assignment dun sa pangatlong set, siya yung magiging element nung pangatlong element ng ordered triple. And so we are sure that 2, 4, 2 is an element of A1 cross A2 cross A3. All right? And then now, hopefully, it now becomes clearer na napaka-obvious naman pala nung equivalence. Kasi ang A1 cross A2 cross A3 ay lahat ng mga ordered triples na yung unang element nang gagaling kay A1, pangalawang element nang gagaling kay A2, pangatlong element nang gagaling kay A3. And so it is but natural to define a choice function kasi nga si A1, meron ka ng isang member na nagre-represent sa kanya. Kay A2, meron na tayong isang member na nagre-represent sa kanya, which is the second component of the ordered triple. And the same thing goes for A3. All right? So if you were tasked to define all choice functions, then kung mahirap siyang enumerate mo na lamang yung lahat ng elements ng cross product. Tapos mula doon sa cross product, ma-define mo yung choice functions. And you can also do it the other way around. If you know the choice function, then ma-define mo lahat ng mga elements ng cross product. All right? And ZF9 or another version of ZF9 tells us that if you have a non-empty family or a family of non-empty sets, then the Cartesian product is non-empty. All right? Now to end, let me just make this remark that the following results can be shown to be equivalent. The axiom of choice, Zorn's lemma, and the well-ordering principle. Meaning you can prove that the axiom of choice is true if and only if Zorn's lemma is true. You can prove the biconditional statement Zorn's lemma if and only if the well-ordering principle. And lastly, you can prove that the axiom of choice if and only if the well-ordering principle. So yun yung ibig sabihin ng equivalence. Now, logically, they are complete complete substitutes for each other. Meaning, remember in ZF set theory, we have the axiom of choice as the ninth axiom. If you don't agree with the axiom of choice, well, you can replace it by the well-ordering principle, right? So yung ZF9, wag axiom of choice ang gamitin mo. Pag ginamit mo yung well-ordering principle, and we now know by this remark that the axiom of choice is equivalent to the well-ordering principle, then ZF1 until ZF8 plus the well-ordering principle will give us the same Zermelo-Frankel set theory as what we would have gotten with ZF1 until ZF9. Yun yung power ng equivalence nila. All right? Of course, you can also do it by the Zorn's lemma. All right? Pero yun nga, ang kwento talaga ng axiom of choice, ginamit siya or finormulate siya ni Zermelo para ma-prove yung well-ordering principle. All right? So we will not prove them. I would just like you to appreciate the statement of these nice principles, all right? So yeah, there's no much point into proving them kasi nga sila ay equivalent, yung Zorn's lemma at well-ordering principle ay equivalent sa axiom of choice, which is assumed and is not proven, all right? And the beauty of these three results is that they are pervasive and they are interwoven into the basic fabric of mathematics. So makikita nyo siya kahit sa ang branch ng mathematics, right? And I think that's it for your binge watching assignment for the weekend. So I hope you guys will watch this video before we go before the first lecture this coming week, because I will be starting with the set of natural numbers. We will try to reconstruct the set of natural numbers axiomatically. That is, we will develop a set of axioms that will give us the set of natural numbers that we know right now. Okay. And I don't want to give any spoilers, so I will end the recording here. So thank you guys. I hope you're enjoying your weekends. Let's see each other again in the lectures this coming week. Bye, everyone.